Alright, so with this one, what we have now is that we've got this figure with a circle that is circumscribed around a rectangle. And we're told that the radius is 4, and we want to know, we want to be able to maximize the area of the rectangle. So what are the dimensions of this rectangle? Now, one thing we have here is that if we were to drop this leg and make a right triangle, okay, if the entire length, whatever the entire length of this rectangle is, this length is half of it. So this leg, you could say, is your x. And then the other one is half of this entire length, so this would be y. Okay, and the whole thing would be 2x and 2y. Okay, so the area of the rectangle would be 2x times 2y. Okay. So now we've got to find what's the relation between x and y. Well, it's going to be 4 squared is equal to x squared plus y squared. Okay. And then we want to solve for either x or y, obviously. And so we're going to solve for the y. Y would equal the square root of 4 squared minus x squared, okay, which we can say is 16, just to keep things simple. And now we take this and plug it in for the y, getting us our area is equal to 4x, which is 2 times 2, times the square root of 16 minus x squared. Okay. Now, what we're going to do is that we're going to want to take the derivative of this. Okay. So when we take the derivative of it, we're going to have to use the product rule. And so the derivative, a prime, would be 4 times 16 minus x squared, or the derivative of the first times the second. And then it's going to be plus the derivative of the second times the derivative of the first. And what comes up as ends up being a minus 4x squared all over the square root of 16 minus x squared. Okay. And now we set this equal to 0. All right. Now this leads us to solving, which gets us a 4 square root of 16 minus x squared is equal to 4x squared all over square root of 16 minus x squared. Multiply, 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 getting us a 4 times 16 minus x squared is equal to 4x squared. Multiply this through, getting us 4 times 16 minus 4x squared is equal to 4x squared. Added 4 times 16 is equal to 8x squared. Divide, divide, getting us an 8 is equal to x squared. So we take the square root, giving us x is equal to 2 root 2. Okay. So that's what our x will have to be. It has to be 2 root 2. Now, once we figure this out, then we can plug it in and see, okay, what is our area, and then we want to check our other ones. But this is going to be our maximum, will occur at this point. And when we check to see what this gets us, so when we plug this in for this x, 8 squared is, or square root of 8 squared is 8, so it'd be 16 minus 8, which means y is also 2 root 2. And so since they're the same, okay, it means we basically have a square, and that's going to maximize our area. And so our dimensions would be 2 root 2 by 2 root 2. And again, once you get this, which is this is your critical point, your CP, you check that by plugging it into your area formula, or we would use this area formula. We would check it in there to see if we maximize the area, or we plug in our other points, which would be 4 times 0 and 0 times 4, which obviously our endpoints would not be that. Oh, these are x and y, so that means we'd have to double these because our sides are doubled because it's 2x and 2y, which means it would be 4 square root 2 and 4 square root 2. Okay, so that would be this is your answer right here. That is your max and min. All right, now this one, we've got a line y equals x, and we want to find where is the shortest distance from the point 1, 0 to there. And so what we're going to do is we're going to use the distance formula. The distance formula is d squared is equal to the change in the x values, which would be along this line, x minus 1 squared plus y minus 0 squared, which is just y. So we know that d is equal to the square root of x minus 1 squared plus y squared. Well, y is equal to x, so we can replace y with x. And now we distribute this through x squared minus 2x minus 1 plus x squared, getting us a 2x squared minus 2x minus 1 square root. Our critical point will be wherever we zero out the inside. So when we take the derivative of the inside, that gets us a 4x minus 2, which means x is equal to a 1/2. Now when x is 1/2, what does y have to be? It also has to be 1/2. So that means that the shortest distance would occur at the point on that line of 1/2, 1/2. Okay. So that is where our shortest distance from the line x equals y would equal, or the shortest distance from y equals x and 0.10 occurs at 1/2, 1/2. Okay. Pretty simple, just the distance formula. And this one you're going to be using the exact same method. So here we go with number 13. They give you the image in your book of what this one looks like. I mean, it's not going to be super helpful, but at least it gives you a visual of what it kind of looks like. And so we're going to be doing the same thing that we did on the previous one, where we use our distance formula, which would be, since we're at the origin, it's going to be from this line, whatever the x and y are, the distance formula, which will be x squared plus y squared, which is the Pythagorean theorem. Okay. And since we're at the origin, we don't have to add or subtract anything. That's what we did on the previous one, is that we had to subtract 1 and then subtract 0. This one we don't have to do that because we are at the origin. And so our distance formula would equal the square root of x squared plus natural ln of x minus x, that whole thing, squared. Okay. And now we're going to do the derivative. And again, all we have to focus on is on the inside of it, okay? Because the inside is where we're going to minimize our distance. And so the derivative of the inside would be 2x plus 2 times natural ln of x minus x times the derivative of the natural ln of x is 1 over x minus 1. And so there is your derivative. And now we set this equal to 0. And this is where you'd probably want to use your calculator. Okay, you would punch this into the y equals function, graph this line, and then see where your 0 occurs. And your 0 should occur when x equals approximately, we'll use the approximate sign. You will have to use your calculator. That's what it means by CAS next to the problem, which occurs at about 0.632784. And that means when we plug this back into this equation to find what y is about negative 1.090410. So you will have to use your calculator for this one. And so again, once you set it up and once you show okay, this is where my 0 occurs, or this is the derivative. From there, you set it equal to 0 and find where it's located. Okay, and so there's your answer for 13. Pretty straightforward, pretty simple.